Okay, this is a solution to the derivative quiz that I gave out for my Calculus 1 class this semester. We have a total of 10 questions, and this right here includes all the differentiation techniques that you have to know, such as the power rule, product rule, quotient rule, chain rule, implicit differentiation, and all that. And of course, you guys can go download this file in the description and work out the questions along the way. And if you're on my Patreon, I will be posting the written solution later on over there, so you guys can, just have the PDF, and then that'll be nice. Okay, first question. A lot of students got this one wrong because they see that right here, y, and then they just forgot about the y. But notice here we have the y, and it says y is equal to sine of x squared plus y squared. You see, we have the y at two different places, so we will actually have to use implicit differentiation because the y is not isolated. So let me write it down again. Y equals sine of x squared plus y squared, and here we go, implicit differentiation in action. d dx, on the left hand side, the derivative of y with respect to x is just dy dx. Now, for the derivative of sine, that will be cosine, and the input stays the same, so we have x squared plus y squared. Then we will have to use the chain rule. We have to multiply by the derivative inside. But it has two terms, so make sure that you open the parentheses and then draw in the derivatives there. The derivative of x squared with respect to x is just 2x. And then we add the derivative of y squared with respect to x is 2y dy dx, because y is a function of x and we are using the chain rule here. Okay, then notice we have dy dx here and dy dx here. To isolate that, we will have to put them on one side. But for this, we will have to distribute the cosine of x squared y squared first. So we are looking at dy dx equals 2x times cosine of x squared plus y squared, and then we add 2y dy dx times cosine of x squared plus y squared. And then we will have to move this to the left hand side. And when we do that, then we will get dy dx minus 2y and then dy dx times cosine of x squared plus y squared, and the right hand side is still 2x cosine of x squared plus y squared. Alright, now on the left hand side, notice that they both have the dy dx, so we can factor that out. So let me put it here. So we will have dy dx, but usually I like to put down the dy dx at the end, because otherwise, if you have the dy dx at the front, this notation looks kind of like that, right? But we took the derivative already. dy dx is what we want. It's the object. ddx is the adjective, it's the verb, it's the action, it's the operator. So let me write it down like this. I will open the parentheses. Here is technically a 1, so we have 1 minus the rest, right? So just 2y, and then we have cosine of x squared plus y squared, and then we have that times dy dx. So this is on the left hand side, and that's equal to the right hand side, which is the 2x cosine of x squared plus y squared. Lastly, we just have to divide this quantity on both sides, then we will be done. So ladies and gentlemen, we can just conclude that dy dx equals this thing on the top, 2x cosine of x squared plus y squared over this quantity, which is 1 minus, that was an x. Here we have 1 minus 2y cosine of x squared plus y squared. Yay! But I don't box this. I'm supposed to be looking for one of the answer choices here. So which one? Well, it looks like to me is answer choice A. So I'll box the answer right here. A lot of students, they just took the derivative, they just say this part, that's of course incorrect because we have the y on both sides, so make sure you do implicit differentiation. Good. Now, For the second question, we have e to the x over 1 plus x. So we will have to use the quotient rule. And the quotient rule says we will have to square the bottom right away. So let's go ahead and do that. So we have 1 plus x squared on the bottom. For the top, we will have to put down the bottom function, which is 1 plus x. And then we multiply by the derivative of the top. The derivative of e to the x is just e to the x. So we have this times e to the x. And then minus the top function, which is e to the x, times the derivative of the bottom. The derivative of 1 plus x is just 1. So that's what we have. Okay, then we will just, of course, distribute the top and then try to combine terms. So here, we will have e to the x plus x e to the x minus e to the x all over 1 plus x in the parentheses square. And notice e to the x minus e to the x cancel very nicely. So we just end up with x e to the x over parentheses 1 plus x squared. So this right here will be the answer. But again, we will have to choose the best answer from here. So that's answer choice B. Alright, cool. Now, number 3. Here, our function is f of x is equal to e to the square root of 1 plus 2x. This right here is rather tricky because we have to use the chain rule twice. Here we go. F prime of x. First, when we take the derivative of e to the whatever, we'll just get e to the whatever first, right? So we'll just write that down right away. We have e to the square root of 1 plus 2x. Then we look at what we have in the exponent, which is the square root function. Take the derivative of that because it's a chain rule. The derivative of the square root, the big picture is 1 over 2 times the square root of whatever we have inside. So that will be 1 plus 2x. But we are not done yet because we have to look at the inside one more time. Look at the inside one more time like this. Okay, and then we will multiply by the derivative of that, which is just a 2. The derivative of 1 plus 2x is just a 2. But you see that this 2 and that 2 cancel very nicely, and it looks like we have the result. This thing will go on the top, so it's just e to the square root of 1 plus 2x over that thing on the bottom, square root of 1 plus 2x on the bottom. So just like this. We are done, and that's answer choice E. Oh, look, this is equal to that. That's cool. Okay. Now, number 4. We have y is equal to the inverse tangent of 2x plus 1. We will have to know the derivative of that. Of course, this is all about taking the derivative. For the inverse tangent, let me just remind you guys this on the side. When we take the derivative of an inverse tangent of x, this right here is 1 over 1 plus x squared. Alright? But of course, we have more stuff inside. So make sure that you just kind of use the box method. It's like d box. That sounds cool, d box. But anyway, inverse tangent of a box. This thing gives you 1 over 1 plus a box squared. Alright? So keep that in mind. Okay. Take the derivative inverse tangent. We first get 1 over 1 plus. We don't put the box when you write down the final answer. We write down parentheses, all right, and then square. And what goes inside? Well, this right here goes inside 2x plus 1. And use the chain rule. Multiply by the derivative of 2x plus 1, and that's just a 2. So far, so good. Then we will just have to simplify this expression, and that will be pretty much it. On the top, we have 2. On the bottom, we have 1, and we will have to expand this. So 2x plus 1 squared, use the formula, we get 2x squared, we get 4x squared plus twice this and that, so 2 times 2x times 1, so altogether we get 4x. And lastly, 1 squared is just 1, alright? And it looks like we can add a 1 together, so 2 over 4x squared plus 4x plus 2. This is not it. If you choose answer choice E, that's actually wrong. That's the tricky answer choice because E is for the people who have forgotten the chain rule. We need this 2 right here. This right here can actually be reduced. On the bottom, we have a factor of 2 we can take out. So we get 2x squared plus 2x plus 1 inside, like this. And then we can cancel out the 2. And then we can say that's 1 over 2x squared plus 2x plus 1. Therefore, the answer is D. The answer is D. All right? Good. Number 5. We'll be taking the derivative of secant to the 4th power of x. Well, maybe let me just write this down right here for you guys as well, because this is again quite tricky. The derivative of secant x, this is secant x times tangent x. All right? And then this notation, it's the same as saying we have to take the derivative of secant x inside and then raise to the 4th power on the outside. So make sure that you notice that this little 4 means this thing right here. Okay. First, we will have to take the derivative of the outside. So put the power to the front and then minus 1. So we get 4. And the inside stays the same. So we have secant x inside. 4 minus 1 is 3. So we have that to the 3rd power. Then we multiply by the derivative of secant x, which is what I told you guys earlier, is just secant x times tangent x. That's pretty much it. But notice, this is to the 3rd power, this is to the 1st power, so together is to the 4th power. So we can write this as 4 times secant to the 4th power of x times tangent of x. So this is it, and the answer is A. Number 6, we will be taking the second derivative, right? That's what the little 2 means. And let me just tell you guys what this really means. d2 dx2 means that we will have to do the derivative of the first derivative. That's why you see the d with a little 2 right here, because you see the d twice. And for the bottom, you see that you have the dx twice. That's why you have the dx squared. And nobody writes dx squared like this. Nobody. So don't do that. So really, we are trying to take the derivative of the inverse cosine of x. Let's do this inside out. First, we still have the derivative on the outside. And for the inside, this is rather just like a matter of knowing your derivative really well. The derivative of inverse cosine x is negative 1 over, I'm still trying to get used to this iPad thing. But anyway, negative 1 over square root of 1 minus x squared. Alright, now, we will have to do this again. To take the derivative of this though, in fact, let's rewrite the inside in the power form. It will be easier that way. The negative stays. When we have the square root on the bottom, we can put that as the negative 1/2 power. So we can write this as parentheses to the negative 1/2 power and inside 1 minus x squared. And the purpose of this is that we can just do the power rule and the chain rule. This way we can avoid the quotient rule, right? Because this was a quotient earlier. This is easier. Okay, negative times negative, we get positive, so be really careful with the sign. I know everybody knows negative times negative is positive, but a lot of the students missed the sign right here, so be really careful. We have 1/2 times, inside stays the same, 1 minus x squared, and then the power is negative 1/2 minus 1, that's negative 3/2. Now, multiply by the derivative inside. The derivative of 1 is 0, the derivative of negative x squared is another negative 2x. So be careful. And you see, this 2 and that 2 cancel, but we have this negative. Be extremely careful. So what's the answer? On the top, we have negative x. This has negative exponent, so we can bring that down to the bottom. So we have this over 1 minus x squared raised to the 3 over 2 power. So that's pretty much it, but unfortunately, this is not one of these answer choices here. So we will have to rewrite. Well, when we have a half power here, that's the same as a square root. So we can write this as negative x over, let's put the square root down first. And then we will just write parentheses 1 minus x squared and then to the third power. Sometimes the third power can be put on the outside too, but here you see that the answer is just option B, so we are done. Yeah. Next, we will be finding the second derivative of sine of x to the third power. So first derivative in action, let me just write it down right here. F prime of x. Well, the derivative of sine is cosine, and then the inside stays the same, right? So x to the third power. Then we multiply by the derivative inside because of the chain rule, and the derivative of x to the third power is 3x squared. So that's pretty much it. Usually we like to have the polynomial terms goes first also. Let me rewrite it. F prime of x equals 3x squared times cosine of x to the third power. We're not done yet. One more time. F double prime for the second derivative. Here we will use the product rule because this is 3x squared times cosine, right? So product rule in action. We keep the first function, 3x squared, and we multiply by the derivative of the second. The derivative of the second is negative. The derivative of cosine is negative sine, so negative sine. And the input is x to the third power stays. But don't forget the chain rule, multiply by the derivative of x to the third power, which is 3x squared. Then we add the second function, which is cosine of x to the third power. And let me write this down in red because I did that earlier. So the second function is cosine of x to the third power. And we multiply by the derivative of the first function. The derivative of 3x squared is 6x squared. That's pretty much it. Well, at the end we can actually simplify this a little bit. 3x squared times 3x squared is 9x to the fourth power, and we have a negative here. So altogether, negative 9x to the fourth power sine of x to the third power. And then this, I can put that to the front. So plus 6x squared times cosine of x to the third power. That's pretty much it. And if we take a look, this is the same as the first one, right? 6x cosine x to the third power minus 9x to the fourth power sine of x to the third power. Number 8, we will be finding y prime, which of course is the derivative. It's just the first derivative though, of y is equal to x squared times 1 plus 3x to the fourth power. Notice we only have one y here. And the best part is, on the right hand side here, what do we have? Let's take a look at this. Can we do algebra before we do calculus? And you should say yes. And if you do the algebra first before calculus, it would be so much easier. So in fact, we can actually just distribute the x squared into the parentheses, and we can look at this as y equals x squared times 1, which is just x squared, and x squared times 3x to the fourth power is 3x to the sixth power. Yeah, but this is not it yet. Take the derivative, y prime equals derivative of x squared. This is everybody's favorite. It's just 2x, and you don't even have to use the definition of derivative. Next, what's the derivative of this? Well, let's do this in your head. Yes, 18x to the fifth power, and we are done. Answer choice D. Yay. Number 9. Alright, this is the last page. Number 9, number 10. Yeah. And notice that, they look so similar, huh? The inside here we have this, and this. They are the same, huh? But for number 9, we have ln. Number 10, we don't. Be careful. Let's focus on number 9 first, of course. What can we do when there's a natural log? Well, we can use the log property. Again, if we can use algebra first before calculus, then that's much better. So, in fact, we can do the same. ln of a quotient is the same as ln of the top, which is the square root of x, minus ln of the bottom, which is 1 plus x squared. This is just the log property that we're using. Well, can we do more? And the answer is yes, because the square root here is the same as the 1/2 power. So let me just erase that right here and then say the inside here is actually ln of x to the 1/2 power for the square root. Yeah? Can we do more? And the answer is yes, because we can actually put the power 1/2 to the front. But here, do not minus 1. This is just the log property. This is just algebra, so do not minus 1, all right? So in fact, I can write f of x as 1/2 times ln x. And when there's only one thing inside, you don't need to put a parentheses. This is okay. And then minus ln of 1 plus x squared. Then we take the derivative. So here, f prime of x. 1/2 is just a constant multiple, so we keep it. And then multiply by the derivative of ln x is just 1/x. So I can just put the x down right here. Right? So 1/2x, done. Minus derivative of ln is just 1/whatever the inside is, which is 1 plus x squared. But don't forget the chain rule. Multiply by the derivative inside, which we have to multiply by 2x. So it looks like our f prime is 1/2x minus 2x over 1 plus x squared. But this is not one of these, right? So, what do we do? Well, combine the fractions and now see what happens. For the first fraction, we will need this guy for the denominator. So let's multiply this by 1 plus x squared on the bottom and also on the top. For the second fraction, we will need this 2x. So let's multiply by 2x on the bottom and also on the top. This way, they will both have the same denominator, and that is 2x times 1 plus x squared. For the top, for this thing, 1 times that is just that, so it's 1 plus x squared. And minus 2x times 2x, so that will be minus 4x squared. Altogether, we see that this and that can be combined. Therefore, 1 minus 3x squared over 2x times 1 plus x squared. And that's it. But of course, make sure that you choose the right answer before you move on. That's answer choice A. Yay. Now, ladies and gentlemen, if you take a look at number 10, when there is no natural log right here, for this one, we will have to just go through the quotient rule, all right? So, let's see. Let me just write down the answer right here. Let's focus on number 10. Quotient rule says we will have to square the denominator. So we have that, and then it's 1 plus x squared, and then square. On the top, we keep the bottom function, that's 1 plus x squared, times the derivative of the top. The derivative of the square root is 1/2 square root of x. Continue, minus the top function, which is square root of x, times the derivative of the bottom. Derivative of 1 is 0, derivative of x squared is 2x. Alright, so again, this is pretty much it for the derivative. The rest is just going to be the algebra. Here we have a complex fraction, meaning that we have a small fraction instead of a big fraction. And the way to simplify this is that let's multiply the top and bottom by that denominator. So let's multiply the top by 2 square root of x, and the bottom also by 2 square root of x. When we take this times this whole quantity, the 2 square root of x will cancel out. So it's actually quite nice. For the first part, we will just get 1 plus x squared. Again, this and that will cancel. Next, it's a minus, and we will have to multiply this and that, right? Earlier we did this, so that was okay. Now, this is a little bit tricky, so let me put it down on the side for you guys. When we have square root of x times 2x times 2 square root of x, square root of x times square root of x is just x. And then we have 2 times 2. So let me just write this down. This and that is just x. And then 2 times 2 is 4. And then we have 1 more x. So altogether we get 4x squared. I hope that's clear. So this right here is this x. And then this x is this x. And then 2 times 2 is the 4. So that's that. So we will minus 4x squared. And then the bottom is nice. I will just write down the 2 square root of x first. And then 1 plus x squared. And then square. At the end, this and that can be combined. Ladies and gentlemen, 1 minus 3x squared over 2 square root of x times 1 plus x squared and then squared. This is it. And if you guys noticed, yeah, the answer choices are very similar as well. Yeah, I did this on purpose. And the answer for this one is C. C. Yeah, be careful. And this is how you get a 10 out of 10 on my derivative quiz. So if you are my student, hopefully this clears up your questions. And if you are my viewers, hopefully this right here is helpful for your Calculus 1 class. And if you are a Calculus teacher, feel free to use this for your Calculus class as well. Again, I will be saving the PDF for my written solutions to my Patreon. So if you subscribe to my Patreon, you will also get the solution. But everybody will get the questions. It's in the description. So yeah, that's it. See you guys next time.